Hello everyone, my name is Ayush Kumar. I am a third year engineering physics student at IIT Roorkee. Today I am going to talk about one of our experiments of Applied Instrumentation Lab, that is study of LDR characteristics. So I will cover the entire explanation of this experiment in the following way. First I will talk about the aim of the experiment. Then I will explain the experimental setup of this experiment. Then I will explain the theory of LDR. Then I will show you the demonstration of this experiment. Then I will show you my observations. And finally, I will talk about some of the applications of LDR. Now, talking about the aim of the experiment. The aim of the experiment is basically to observe how the resistance of an LDR changes with the varying intensity of light and to draw characteristic curve between resistance and light intensity at different voltages. So now we are going to see the experimental setup. So you can clearly see the experimental setup here. So in this experimental setup, we have our main circuit, our input source, voltmeter and ammeter. So we have to connect our all of these like input source, voltmeter and ammeter without main circuit. So first we have connected our input source with these two and these two connecting wires. Then we have connected our voltmeter with these two wires. You can see it here. And then we have connected our ammeter with these two connected wires, like you can see it here. And this is basically our LDR. So our LDR is connected in our main circuit in this way, and this is our light source which we place perpendicular to the LDR. So now that I have covered the experimental setup of this experiment, I will move towards the theory, and here I will explain the theory behind this experiment. So first let us talk about the construction of LDR. So LDR, as we all know that LDR stands for light dependent resistor. It is a special type of resistor that works on the photoconductivity principle. Means that resistance changes according to the intensity of light. Its resistance decreases with an increase in the intensity of light. These light-dependent resistors are made with photosensitive semiconductor materials like cadmium sulfide, lead sulfide, etc. And they are placed in a zigzag shape, as you can clearly see in this diagram. Now talking about the working principle behind LDR. So LDR works on the principle of photoconductivity. Whenever the light falls on its photoconductive material, it absorbs its energy and the electrons of that photoconductive material in the valence band get excited and go to the conduction band, and thus increasing the conductivity as per the increase in light intensity. The energy of incident light should be greater than the band gap energy so that electrons from the valence band get excited and go to the conduction band. You can clearly see the circuit diagram of a basic LDR experimental setup in this diagram. So now I will show the demonstration of this experiment. So let's see. So now I will demonstrate the working of LDR. So I have this scale, and I will light this torch, and I will see the changes in the readings of current here. So now I will turn on the light, and I will measure the readings from here. So this will be corresponding to the maximum current. So as I am increasing the distance, so you can see that the intensity of light is decreasing, so the darkness is increasing, and as well as the resistance is increasing, and thus the value of current is decreasing. So this is how this experiment is performed. As I already told in this video, that the light source is placed direct in front of the LDR. Initially, we place the light source in contact with the LDR, which corresponds to the 0 centimeter reading. Then we slowly move away our light source from the LDR and note down the readings of both the displacement as well as the current. All of this is carried out at a particular voltage. Then we repeat the same experiment in the similar way at different voltages. Now coming over to the observations of this experiment. So these are my observations. You can clearly see that as the distance of the light source from the LDR is increasing, the current is decreasing. As we have our voltage as well as the current, we can calculate the value of resistance at each reading. Here in the last column, you can clearly see that the resistance is continuously increasing with the increasing distance, or you can say with the decreasing intensity. Now let us look what type of variation of resistance is actually happening here. For that, we need to plot these readings on a graph. So here in this graph, you can clearly see that there is a rapid decrease in resistance with the increasing intensity. Or you can say that the resistance is increasing rapidly as we are increasing the distance. So this was all about observations of this experiment. Now lastly, I want to tell you some of the applications of LDR. So let's see some of them. So LDRs are often used in light activated switches for turning lights on or off based on ambient light levels. They can be employed in streetlights to automatically turn them on when it gets dark and off when it gets bright. LDRs can be utilized in security systems to detect unauthorized entry by sensing changes in ambient light levels. In photography, LDRs can be used for exposure control. They help cameras to adjust the aperture or shutter speed based on the available light, ensuring proper exposure of the photograph. LDRs can be integrated into solar panels to track the position of the sun. By sensing changes in the light intensity, they can adjust the orientation of the solar panels to maximize energy absorption. So this was all about the experiment study of LDR characteristics from my side, and that's it. Thank you.